We're given two functions, f of x and g of x, and we're asked to find the domain of their quotient, f divided by g of x. So before we talk about what I've already written down, let's look at this function g. Remember that x to the 3/2 power is the same thing as the square root of x cubed. That's very important to remember. Now, whenever you're looking for the domain of a function, you always ask yourself three questions. Is there an x under an even radical? Do you see how we have this x under a square root? Square root is an even radical because there's a 2 right there. You could have a 4th root, a 6th root, an 8th root, anything like that would make this an even radical. The next question is there an x in a denominator? In this case, neither of these have an x in a denominator. And then third question is there an x in a logarithm? And we don't have any logarithms in these functions, so the answer would be no to that one as well. In this equation, or this function, we don't have any of those restrictions. There's no x under an even radical, there's no x under in a denominator, and there's no x in a logarithm. That's why the domain of f is everything. It's all real numbers. Now look at the domain of g. We do have an x under an even radical. That means that the radicand, the stuff that's underneath the radical, is not allowed to be negative. It cannot be negative. So that means that x cubed must be greater than or equal to 0. You can take the square root of 0 cubed, and you can take the square root of any other positive number cubed. It's just when you take the square root of a negative number that you end up with imaginary solutions, and we don't need that, right? So we have to restrict the domain, or the x values, to positive numbers. This tells us that x must be greater than or equal to 0. So to find the domain of f divided by g, we just need to find the intersection of these two pieces of information. Well, let's look at a number line. If we were to graph the domain of f, I'll just use the pink color for that one. That's everything, right? The domain of f is everything. Well, what about the domain of g? The domain of g says we have to start at 0 and go to infinity. And since it has or equal to, we can put a bracket and go this direction. The intersection of those two domains is just what they have in common. So what do those two have in common? If you were to take these two graphs and smash them together, they only have in common from 0 to infinity, correct? There we go. So 0 to infinity is what they have in common. So we're going to say that the domain is going to be 0 to infinity. Well, we have to make sure that this works when we actually find this quotient. When you have a quotient, there could be an extra little piece of information that you need to consider. So right now, this is the domain that we're thinking it is. Well, go back and actually find this quotient. F divided by g is going to be 3x over the square root of x cubed. Okay, now we actually answer yes to, is there an x in the denominator? That means that the denominator cannot be 0. So the square root of x cubed cannot be 0. If you square both sides, you get x cubed cannot be 0. Take the cube root of both sides and you get x cannot be 0. But because of this bracket, we're saying that it's okay for x to be 0. So we need to edit the domain that we came up with and just make it from 0 to infinity and not including the 0. Because once we actually find the quotient, we end up with an x in the denominator. So our domain is going to be parentheses, or parenthesis, 0 to infinity. Remember, the bracket means you include your endpoint, like we included our endpoint here, and a parenthesis means you do not include the endpoint. So you include everything as close as you can get to 0, but you don't actually include the 0. Okay, so there was another question about the union symbol. What does the union symbol actually mean? So let's think of an example for union. Let's see, if we have x is greater than 3 and we have or x is less than -2. I want to show the difference between this and if we were to put an and in the place of that. So if we have x is greater than 3, I'll graph this one in, actually let's make this or equal to. X is greater than 3 looks like this. So let's graph this one in green. X is less than or equal to -2 looks like this. Remember, the or equal to means we have a bracket. So what does it mean when we say x is greater than 3 or x is less than or equal to -2? Or means x can make either of these true and we'll take it. That's all it means. If x makes either of these true, we'll take the answer. That means our x can be in this graph or it can be this graph. So if you have an or here, that's the same thing as a union. So we have -infinity to -2 bracket union parenthesis 3 to infinity. This would be the way you would write all of this information in interval notation. Or means union, and union means you take everything in both. So what if we had had an and in there instead? What if we had x is greater than 3 and x is less than or equal to -2? We still have the same graphs. X is greater than 3 still looks like this. X is less than or equal to -2 still looks like this. But because we have an and means intersection. And intersection means what do they have in common? Well, what do these two graphs have in common? Absolutely nothing. If you were to smash them together, they don't have anything in common. That means the intersection of these two intervals is the empty set, because they have nothing in common. So what if we had x is greater than -3 and x is less than or equal to +2? So this time we have the -3 here and the 2 here. We have x is greater than -3, so parenthesis this direction. We have x is less than or equal to 2, which is bracket in this direction. Remember, we have the and, that means intersection, and intersection means what do they have in common. By the way, the symbol for intersection is opposite the union symbol. This means intersection. And this means union. Okay, we want the intersection because we have the word and. We use union for or. Alright, so if we were to take these two and smash them together, what do they have in common? Well, they don't both have -3 in common because this one does not include -3. So we put a parenthesis we smash these together, they have all of this in common. So then we get to the 2. 2 is included in both because there's a bracket there and a straight line here. There's no break in this line, so we put a bracket here. This would be our interval that describes this instance. So what if we had x is greater than -3 or x is less than or equal to 2? Now we're back to the union again. So how is this one different? So we have the same graphs. -3 to infinity looks like this. X is greater than -3. X is less than or equal to 2 looks like this. Or means you want everything in both. So what you do is you smash these together and you take everything. Here you smash them together and take just what's in common. These you take everything. So if you start here and go forever left and you start here and go forever right, doesn't that include both of those and the entire number line? So in a case like this, you would get -infinity to infinity. You would actually get the entire number line.